Download this code from codegive.com, link in the description below. Certainly. Database page splits are an important concept in database management systems, dbms, particularly those that use B-trees for indexing, such as SQL Server and PostgresQL. Understanding page splits is crucial for backend engineering as it can significantly affect the performance of database operations. What is a database page split? A page in a database is a fixed size unit of storage, typically ranging from 4 KB to 8 KB. When records are inserted into a database, they are stored in these pages. A page split occurs when a page becomes full and cannot accommodate new records. To resolve this, the dbms will split the page into two, moving half of the records to a new page and updating the index accordingly. Why do page splits happen? 1. Inserting new records. When a new record is inserted and the page is full, a split is necessary. 2. Updates. If an update increases the size of a record such that it no longer fits in its current page. 3. Fragmentation. Over time, frequent insertions and deletions can lead to fragmentation, which can also necessitate page splits. Consequences of page splits. Performance overhead. Every page split requires additional I/O operations, which can slow down data insertion and affect overall performance. Fragmentation. Frequent page splits can lead to fragmentation, which can increase the time it takes to access data. Increased locking. Page splits can lead to increased locking contention as multiple transactions may need to access the same page. Example of page splits. Let's illustrate page splits with a simplified example using Python and a SQLite database. SQLite uses B-trees for indexing, making it a suitable example. Step 1. Setting up the environment. You will need Python installed along with SQLite 3. You can run the following code snippet to create a simple database and demonstrate page splits. Step 2. Inserting data. We will insert a large number of records to simulate page splits. Step 3. Observing page splits. To observe page splits, you typically would use database profiling tools or monitoring features. For SQLite, you can check the database file size before and after a large number of inserts. You can also use the pragma page_size command to determine the page size of your SQLite database. Step 4. Analyzing performance. After inserting a large number of records, you can measure the performance of subsequent inserts. Preventing page splits. Here are some strategies to minimize the impact of page splits. 1. Batch inserts. Insert multiple records in a single transaction to reduce the number of splits. 2. Use appropriate data types. Make sure that the data types used fit the data being stored to prevent unnecessary growth of records. 3. Indexing strategy. Design your indexes carefully, avoid excessive fragmentation by using fill factors, if supported by your dbms. Conclusion. Understanding page splits is vital for backend engineering as it directly influences database performance. By carefully managing how data is inserted and indexed, you can minimize the negative effects of page splits and optimize your application's performance. This tutorial provides a basic introduction to the concept, along with a practical example using Python and SQLite. You can explore further with other databases like SQL Server, PostgreSQL, or MySQL for more advanced features and monitoring capabilities.